for DeLaval, automatic milking equipment in North America. Today's seminar, Automatic Milking, Current Status and Future Options, is sponsored by DeLaval. The speaker today is Dr. Doug Reineman, Professor, University of Wisconsin-Madison. Doug has been a professor at the University of Wisconsin-Madison in the Biological Systems Engineering Department for the past 2 decades. During his tenure, he has directed the activities of the UW Milking Research and Instruction Lab, and he has served as the U.S. representative and chair of the International Dairy Federation's Working Group on Machine Milking and the U.S. representative to the International Standards Organization committees on milking machine performance and installation, and automatic milking installations. This seminar is being approved for continuing education credits for the American Registry of Professional Animal Scientists and the American Association of Veterinary State Boards RACE program. Forms are available in the back if you're interested in RACE credits. I would like to ask everyone at this time to please silence your cell phones and join me in welcoming Dr. Reineman.
Mark, and thanks to DeLaval for sponsoring this session. It was really a great pleasure for me to put this presentation together and review just exactly where the state of the art is with automatic milking. I usually have many more slides than I can cover, but I took a bunch out, tried to focus really on the critical issues. What I'm going to try to do today is just give you an idea of where the technology is today, where it's going in the future, and then look at a review of the research to give some ideas, some numbers on issues relating to AMS performance, as well as barn design and sort of current thinking, and also the needs for future research in this area. So since I cut out a bunch of slides, that will allow time for questions. And I would encourage you, please, I'm quite happy and willing to take questions. So if a question comes up during the presentation, please feel free to raise a hand. If you have a question, it's likely other people do too. This is a very short time we have together, and we won't be able to cover the whole territory. But I would particularly like to cover the issues that are of interest to you. So this is one of my favorite pictures. I started in the milking machine business in about 1990, and I've done several sort of historical retrospectives on milking machines. And the development of automation began with the milking machine and has really continued up to the present day. And of course, the trend in automatic milking is to let the machines do the labor. The other more important part is to let the management do high-level management activities. So this is the benefit of a robot. It allows management to perform higher-level management activities. That's how you recover your investment in this technology. So I organized a seminar in 1999 at World Dairy Expo, and at that time there were no automatic milking installations in the U.S. And this is the program for my 1999 symposium. We had manufacturers represented. We had a discussion on barn design. We had some producers talk about their experience. And then we had a very lively discussion about the future of robotic milking in the U.S. in North America. And I would have to say that in 1999 there was quite a lot of skepticism. Quite a lot of intrigue. People were really interested in the idea, but there was really quite a lot of skepticism on whether or not these things would actually work. So here we are 12 years later, and the growth in installations has been exponential, which is extraordinary for any product, any new product on the market. So since the first installation in Europe in 1992 and the first installation in the U.S. in 2000, the growth rate has been exponential in both the EU and the U.S. There are right now somewhere around 150 farms, plus or minus 10 or 20 in the U.S. and something like about 350 farms in Canada. And particularly in the last few years, the growth rate in the U.S. has been phenomenal, particularly this part of the country. I made a projection back in about 2004, 2005, based on this exponential growth curve, that more than half of the cows in the country, let's just say North America, let's just say the developed world, North America and the EU, based on the exponential growth from 92 to 2004, I predicted that more than half of the cows would be milked automatically by the year 2020. And if this exponential growth rate, well, actually I said before I retire, which gives me a little leeway. Actually, I probably won't retire in 2020 given the current economic situation. But if this exponential growth rate continues, and there's really no signs of it letting up, automatic milking will become the predominant way of milking cows in this country and in Europe. So some of the other developments since 1999, there are now regulations and standards. I was part of the ISO group that developed a standard for robotic milking installations, and also was part of the group that developed the robotic milking annex for the pasteurized milk ordinance. So the regulatory issues are pretty much settled. They've been accepted as technology by the regulators. And still a few questions, which we'll be discussing a little later in the presentation. So now I want to just look at the current technologies, particularly the current technologies that are available in North America. And that technology right now, if you wanted to build a new system, would be a single box system. And those systems will run with somewhere between 50 and 70 cows per box. And there are farms with anywhere from 1 up to 32 individual boxes. So it's not only small farm technology, although the majority of the installations are on farms with 2 to 4 milking stations, but there are also some very large farms that are using this technology. The two machines that are on the market today, the single box systems, are the DeLaval VMS. And this is not intended to be a commercial presentation, so if you want more details about the technologies, talk to the people out at the booths. They'll tell you much more than I will. But just a few characteristics of the VMS, the DeLaval VMS system. It uses an individual cup to clean teats, and this cup is not used for milking, so there's a dedicated cleaning cup. Sanitizer is injected into the cup pulsates, and the sanitizer is removed. The teat cups are individual, so the teat cups are attached individually, and they go back to the basically the receiver with individual long milk tubes. And one of the options available on the VMS is steam backflush. Cleaning the unit disinfecting the unit is a much more important proposition in an automatic milking system than in conventional parlors, because more cows share the same milking unit. And so transmission of particularly contagious mastitis is a higher risk in a automatic milking system. So the quality of disinfecting the teat cups between milking is more important in an AMS system than it is in conventional system. Another option available for the VMS is an online cell counter. I'm not sure that's on the U.S. market right now, not on the U.S. market, but it will be soon. So this is a technology that was developed by DeLaval that has now been applied to the automatic, or will be applied to their single box system. The other option available on the U.S. market today is the Leigh machine. And Leigh introduced the A4 system at the Eurotier show last year. And the big difference with that system is that it allows straight through cow movement, straight in, straight out, rather than something resembling more like a side opening stall. The Leigh system uses brush cleaning, and the teat cups the 4 teat cups are attached to sort of a magazine at the end of the robotic milking arm. So when the arm goes under the cow, all 4 teat cups are in the same assembly. And Leigh also offers an option for steam back flush. Both Leigh and De Laval offer other sorts of milk quality sensors, conductivity, light color detection, and these are the particular features offered by the Leigh MQC. Also at the Eurotier show, Westphalia Surge displayed their system, which is a little bit different, and it's a multi-box system. So in this system, one robot arm serves several stalls. The configuration of the barn is similar to a single box system, but typically with a larger group size. And the objective is to make more use of the high-cost part of the equipment. So we've got a robotic arm there. Rather than letting it stand idle, the idea is to service several stalls and get better utilization for the investment. There are also other units available in the EU market. None of these are on the U.S. market right now, both multi-box and single-box systems. So there are other manufacturers out there, again, not currently on the U.S. market. The new technology is the De Laval VMR, which you've probably already seen at the show. Voluntary milking rotary. And the big difference between this system and the box systems is that it's designed for multiples of approximately 700 cows. So rather than a modular system with a box and 60 cows per box, now we have a rotary with 700 cows per rotary. And the sort of claims are that they will achieve something like 90 cows per hour milking on this 24-stall rotary. And I expect that number will very likely increase as the technology improves and users figure out better ways to manage the system. It's brand new. There's 4 or 5 running in the world. They have started commercial installations in Australia and some countries in the EU. Not yet available on the U.S. market, but someday, soon, it will be. And this technology, I think, in my view, really changes the picture for automatic milking in the U.S. It opens the door, or I should really say opens the minds of large dairies. While there are some large dairies that are using single-box systems, the mindset of large dairies in the U.S. is to manage cows by group and manage larger number of cows in larger groups. So the concept fits much better into the way that large dairy farmers in the U.S. are thinking about milking cows. I've had a number of very lively discussions with people from De Laval on whether or not they envision this technology being implemented in a batch milking mode or a voluntary mode. And I think the answer is still out. I think it's likely to be adopted in both ways, depending on the management objectives of the farm. So in a batch mode, it would run like a traditional rotary milking parlor. We'd get a pen of cows, something like 90 cows, 100 cows in a pen, put them in a holding area, and in an hour they would be milked and back to their pen in the freestall barn. In the voluntary mode, those cows would have to be selected and funneled in from a number of different pens into the milking station and then directed back to their housing stalls. Another feature of this technology, which I think is very interesting, is that you can add technology incrementally. So one could, if one desired and cash flow dictated, just install the rotary and operate it manually. And then add, you'll see here there are 5 robotic arms on this 24-stall system. 2 of them do the preparation, teat preparation. 2 of them do unit attachment, and 1 of them does post-dipping. So it's a technology where you could start milking manually with a lower-cost system and then add 1 arm to post-dip, add 2 more arms to pre-dip and pre-milking preparation, and then finally add the attachment arms for complete automation. So, this is an idea I've been talking about for a long time, particularly for medium-sized farms. The ability to invest incrementally as the cash flow is available on the farm is a strategy for reducing risk in the dairy business. So I think it's a very attractive idea, particularly for those mid-sized farms that have cash flow issues when they're expanding or modernizing their technology. This is a closer view of the robot arms. And so the way the system works right now, let's just say we start with a full platform of cows. The platform is standing still. The 2 preppers will prep the 2 cows while the 2 attachers are attaching another 2 cows, and the post-dip is spraying 2 cows. Then the platform advances by 2 stalls, get 2 new cows, and everyone gets a turn at the next station on the platform. That's the way it's operating now. I expect with management experience and with technological experience, it may someday, although DeLaval hasn't told me this, but I think it's likely that it could operate in a continuous mode like a rotary parlor and run continuously. We'll see. This is a view of the teat cup attachment arm. Again, it has the same teat cup assembly and attachment assembly as the VMS, so teat cups are attached individually. Teats are washed individually with a dedicated cleaning cup. So with that very, very brief overview of technology, now we have some kind of idea what the robot itself will do. One of the big questions out there, and particularly for producers looking at the technology, is what sort of barn do I build? How do I lay out the barn? And I would just start by saying the barn is as important as important as the robot. So you don't want to go spending a lot of money on high technology and have your technology limited by cow flow and by the operation of the barn. As we'll see in the review of research, a number of researchers have really pointed this out and presented us with some real numbers on the performance difference between a well-functioning cow traffic system and one that does not function so well. The other big issue is cow cleanliness. It's at least as important, perhaps even more important, with a automatic milking system than with a conventional milking system. One of the very handy, I think, design guidelines that has come out of research and experience is when you're designing your barn to avoid dead-ended alleys. And this applies not only to robotic milking, but any sort of freestall barn. Always allow the cows an escape path so that dominant cows don't confine less dominant cows at the end of the alley, keep them from feeding, keep them from milking, keep them from water. So, it's one of the things you want to have in mind when you look at your barn plan. Make sure you don't have dead alleys. The other major difference in categories of barn design are the difference between free traffic and forced traffic. And according to the survey information, early on, most farms started with forced traffic, some degree of forced cow traffic, and the trend has been toward more free cow traffic. So if we have forced cow traffic, we need a system of selection gates. They may be just one-way gates, which is most common, although another approach is to have cow identification at these gates so that the cow can enter the gate and then be selected based on the management information, whether or not that cow needs to go to milking or whether we want to send her off to get some feed. And this is really, I think, an important factor in the utilization of the machine. So if we don't have some sort of selection, then every cow has the opportunity to go through the robot stall, and only a certain percentage of those cows will actually be milked. If the cow doesn't have enough milk in her udder, then she comes in, she's identified, and she goes out somewhere else. And this takes up time in the robot stall and reduces the efficiency of operation of the milking unit. So I think it's certainly worth considering, although the preference in of those users is toward free traffic. I think forced traffic still has some ideas that make it look very interesting. The other extreme is absolutely free cow traffic, so that there are absolutely no gates in the barn. The cows are free to go anywhere they want, feed, milk. And another design feature of many systems is a holding area in front of the robot, so that a group of cows, but not too big a group of cows, can get into this holding pen. And one of the advantages of this is that it reduces the kind of competitive behavior amongst cows. It reduces the possibility for a dominant cow to keep other cows out of the milking stall. So holding area is another commonly used technique to improve cow flow. And really the bottom line, I think, in the barn design is you need to allow a little bit extra space. From my own personal opinion, I wouldn't lock in to one or the other at the start. I would allow enough space in the barn so that one could do either free or some degree of forced cow traffic. And it depends a little bit on the type of system you're looking at. We'll talk a little bit more about that with the AMR. So these are the numbers. When I looked up the research, I have to say, first of all, I was overwhelmed at the number of papers. I did a search on automatic milking, robotic milking, and I came up with something like 3,000 papers in the last 10 years. So there's been an extraordinary amount of research on this subject. And what I've tried to do in this very brief review is just emphasize some of the key points that have come up in the literature, that come up repeatedly in the literature, and particularly those that might influence your decision about your cow traffic patterns in this case. So this was a study done comparing free to forced cow traffic, and the two systems had no difference in dry matter intake. So, dry matter intake is a pretty critical parameter when you're looking at dairy cow production, and at least in this study, there was no significant advantage one over the other on feeding behavior of the cows. The number of milkings, voluntary milkings, and total milkings was slightly higher with free traffic, from 2.4 voluntary to 2.5 voluntary milking, so a pretty small difference. And so there are other things beyond this, but at least as far as feeding behavior and milking efficiency, in this study there were no great differences between free and forced cow traffic. This is another study on forced versus free cow traffic. This comes from Sweden. The average number of visits to the robot did not differ So again, no clear advantage one over the other. There was no difference in cow lying behavior in both systems. 12.3 hours per day cows spent lying. The type of traffic did not alter the duration spent in the feed area. And as sort of a side note, there was a period during the night when feeding was less common. So neither system improved the stability of milkings or the consistency of the number of milkings per hour over the course of the day. Another issue that has come up with robotic milking, particularly for people who've never seen a cow or never seen a farm or never milked a cow, is this issue of animal welfare. And I feel safe in saying that if you go out into the general public and talk about robotic milking, the general reaction is negative from a standpoint of cow welfare. So the average person on the street thinks that milking cows with a robot is somehow worse for the cow than milking with people. And in this particular study, they looked at things like restless behavior, heart rate, and the AMS. Their conclusion was that being milked in an AMS did not seriously impair welfare of cows. There were slight increased stress levels, but all the differences were minor. They looked at two different AMS systems, which were slightly different from each other, and they compared that to a milking parlor. Part of that had to do with just the cows learning a new system. And in the first day of operation, the stress levels were higher in all new systems, and then the stress levels reduced to normal levels for all the systems. So from an animal welfare standpoint, I mean, my personal view on animal welfare is that I think cows prefer automatic milking to conventional milking, particularly if the movement to the milking area is voluntary. I mean, my own subjective, and I've actually done some testing of flight responses of cows in robotic milking barns. And from everything I can tell, when the cows are in the free stall, they are much calmer. They are much less afraid of people. There's also been a number of attempts at using automatic milking on grazing systems, and a fair amount of research that gives us some idea and also some very interesting insights into animal behavior. In this particular study in New Zealand, they were trying to decide whether or not training cows improved their acceptance of the robot, or if they should just put the cow in and let her on her own. And the conclusion is that training improved the ease of entry into the AMS at the first assisted milking. So it made the first visit to the robot a little bit quicker. And the 92% of heifers and 81% of cows were voluntarily milking within 6 days. And the time for a voluntary approach for heifers was 1.9 days, and for cows 2.6 days. So one of the very interesting results of the study is that training did have a moderate influence in the early days of adoption, but the other, I think, fascinating result is that heifers adopted quicker than cows to automatic milking. And this is, I think, is very interesting because if you talk to farmers who've dealt with heifers, the general conception is that heifers aren't, they're not going to go in there. But in fact, the heifers learn the system and adapt the system much better, much faster, much easier than mature cows. This one, another fascinating study. If you look at the economics of automatic milking, I think it's fair to say that at this point in history, particularly in the U.S., it's generally more expensive than conventional milking, depending on what you're comparing to. But over time, the technology is likely to levelize or reduce somewhat, at least in this country. And the efficiency of the system is almost certainly going to improve as farmers learn how to manage the systems. So this was a study in which they were looking at the occupation rate. So 64% of the time, cows were being milked in the AMS. And they did some things to improve the management based on the strategy of which cows to milk and when to milk them. So they did some rather minor adjustments in the management strategy to try to get a higher occupation rate. And the daily milk yield increased by about 100 kilograms per day, and milk revenues increased sort of modestly from 498 to 507 euros. So this is, I think, a very important example of the importance of the management intensity on the profitability of the robot. In order to, like I said at the start, in order to get the return on your investment for this technology requires superior level management. So this researcher sort of speculated that if we could somehow, he didn't actually say how, but if we could get that occupation rate up to 85%, which might be accomplished by something like a very well-managed combination of forced and free traffic system, the revenues would go up to something like 529 euros per day. So, about a 20-30% increase in the revenues based on a superior management strategy. And as part of the speculation, one way to increase the occupation rate, in the first scenario, it was just to make the existing system more efficient with the same number of cows. The alternative proposed here is to add more cows. So instead of 60 cows per box, this is a simulation assuming 80 cows per box. And because of the increased cow pressure, the assumption is that the occupation rate would go up. And in this case, the milk revenues went up to 673 euros. So I think this is really another very critical point, because the question of how many cows per unit, how many cows per box, particularly in single box system, I think the question is still out on that. There's a number of different management strategies. You can operate these systems for very high production per cow, fewer cows. You can operate these systems with slightly lower production per cow, more cows, and the economics are really quite dramatically different using these different management strategies. So this is one of the areas that we're sort of constantly pushing on and advancing, and I expect that these numbers will continue to improve in the U.S. as well as around the world. The final conclusion from this author is recommending a dynamic approach, which means using your data. Using the data, automatic milking machines are data collection machines. And if you don't use the data, you've paid a lot of money for high technology and you aren't getting the utility out of it. So the practical implication on a farm is you're going to start milking your first day and you're going to have sort of a standard cookbook management strategy. But in order to really use the technology, the user themselves should be sort of constantly looking at the data, trying things, and figuring out what worked, what didn't work. There's some basic kind of concepts to work with, but those are individual to each farm to some degree. So it's really important for the individual operator to understand their farm, their management system, and constantly be thinking of ways to make it more profitable, and using the data as part of a feedback quality management program in that scheme. Another issue that has received an enormous amount of research attention and is related to some of the regulatory concerns is the issue of online milk sensing. And the technical problems of unit attachment are solved. I mean, we know how to do that, or they know how to do that. The attachment success is extraordinarily high. Voluntary cow traffic works. We're still tweaking it a little bit, traffic patterns, but it works. Cows will come to the robot. And sort of the primary technical challenge at this point is to develop sensing systems, particularly that are accurate enough for automatic diversion of milk. So the current technologies generally lack specificity for abnormal milk detection and or mastitis detection, and those are slightly different definitions, as we'll see. The systems are generally sufficient for diverting milk with blood in it. The color sensing system is accurate enough that we can tell it, if you see red, a certain degree of red, divert the milk because of blood in the milk. The other thing I really want to point out, though, is that even with the current state of technology, the management tools that the producers have are sufficient for producing excellent quality milk. And if you look at the field studies, generally when a new system goes in, there's a slight deviation in milk quality. Milk quality tends in the first few months to get slightly worse, but as the people learn to use the systems, there's really no detectable difference between automatic milking and conventional milking. And what that says to me, and I actually was part of the group that was monitoring all the U.S. farms for the FDA, what we saw very clearly is farms that had good milk quality before robots had good milk quality after robots. Farms that had poor milk quality after robots had poor milk quality, poor before, poor after. So milk quality, I'm an engineer, I love technology. I would love to develop a technology that would produce excellent milk quality on every farm, but it's very clear that for milk quality concerns and mastitis control, management is the key. Technology is I was going to say irrelevant. It's not irrelevant because a technology gives a manager management tools, but if the tools aren't used, they aren't going to do anything. So the difference in milk quality is primarily in the management philosophy, the management intensity, not primarily a function of the technology. The other problem we've had, particularly in the EU and with the ISO standards, is this question of a double standard. So we would like robots to do well, and they clearly can do well. The question is, do they do a better or worse job than people in detecting abnormal milk? And the answer, of course, is it depends an awful lot on the person. And one of the things you'll see in automatic milking technology is that, in general, the automatic technology is much more consistent than people. So if I have a milking parlor and I have 3 different milking crews, there's a lot of variation between people on their ability to do everything in the parlor, but particularly a detection of abnormal milk. The other big question is how many people actually do, how many operators in milking parlors today actually do check for abnormal milk. And abnormal milk in the EU hygiene directive is based on flakes and clots. So it's really a very difficult thing to detect. A highly inflamed udder with gargut in the milk is pretty easy to detect, and we kind of get those. But the technical definition in the EU hygiene directive is any milk with flakes or clots, a visual abnormality in the milk is considered abnormal. That cow may or may not have mastitis. They probably don't have clinical mastitis. They may have subclinical. They may not have subclinical mastitis. So this is an issue of continuing debate, and there's work going on not only in sensor development to sort of comply to this visual standard, but also a discussion about what we're really defining as abnormal milk. What milk needs to be diverted from the bulk tank that is not suitable for human consumption. So just look at some of the field studies. This was the field study that was done in the U.S. We monitored the first 12 automatic milking farms in the U.S. over a period of 3 years, and we saw no difference in somatic cell count. The total bacteria count was actually lower in the automatic milking systems than it was in conventional farms. And both somatic cell count and bacteria count decreased with user experience. So just like in the European studies, initially there was a little bump up, but after really only a few months, the numbers came down basically to the same as the previous level for that farm. Another study in the EU, similar results, same results, small increases in milk quality measures, but after 6 months of operation, they stabilized around the level of conventional farms. So, that tells me that the technology that we had, even in 2004 and 2003, was sufficient for good managers to achieve their milk quality goals. So looking ahead in sensors, this is a very recent thesis from the Netherlands. And there are a couple of different approaches that you can use to try to increase the sensitivity of mastitis detection and or abnormal milk detection. One of those is to develop new sensors, better sensors. And typically, the best systems right now use a combination of sensors, so they're not using information from just one type of sensor, but combining information from several types of sensors. And that is one way to improve sensitivity. Another way is to get smarter, so new algorithms. So we've got hundreds or thousands of smart people around the world trying to figure out how to take that data from those sensors and, through the magic of statistics, get a more sensitive detection algorithm. And the other approach that was tried in this thesis project was to add information not from sensors but other management level information like the parity of the cow, stage of lactation, historical production records, things like that. So the goal for the sensitivity numbers are sort of nominally 70%. So the result of this study is that by increasing the time window and using these very clever algorithms, they were able to achieve a sensitivity 69.5%, which is almost to our goal. So we're getting there. It will get better. We will get smarter. And I think the sensor issue is well on the way to being solved, and it will provide a more powerful management tool for milk quality managers. Next steps, I thought a good thesis always kind of says, well, what's the next important area of research after we answered this question? And I thought this was very insightful. Is the first next step is gaining insights to the needs of farmers. So what sort of information does the farmers want to better manage their herds? And we can, from our ivory tower, we can look out and say to the farmer, well, you should know about this, that, and the other thing. It would improve your profitability. But the other part of the conversation is equally important. What is it that farmers need to improve their management? The issue of gold standard, I think, is one that will need to be addressed. It's really not, from a scientific standpoint, it's not practical, it's not technically reasonable. So I think that will need to be addressed. And then further optimization of their algorithms and data inclusion criteria. They said, there's still more to learn here. And particularly on farms, more data from farms where quarter milk is visually checked to sort of check against this existing gold standard, which is visual abnormalities in milk. This is another study, another sort of approach, And the problem with this, with an algorithm or a system that has low sensitivity is that you get too many false positives. So on a robot farm, what this means is if you get an attention list, you might have 10 cows on the attention list, and only 3 of those cows actually have the problem, have mastitis or abnormal milk. And so you've spent time checking 10 cows, and only 3 of those were false positive. So this is sort of one of the frustrations of farmers now, is how to adjust the sensitivity of their existing systems to try to reduce the number of false positives, but also not let the true positives go through. So this was a study which combined 2 types of information and also computed probabilities based on, rather than just a yes-no, there's a probability score. This cow is more probable than that one to have the problem. And by using that sort of algorithm, they were able to reduce the false positives by 35%. However, 10% of the true positives were not detected. So this is, again, sort of the balancing act. Reduce the false positives, but don't let the true positives through. And these last were, I thought, sort of very handy recommendations for people milking with automatic technology now. Checking alert list is the best option, but results in workload. So, the best option is check every cow on the alert list until you get too impatient to do that. Alert list based on single alert information misses too many true positives. And a combination of alert information is the best. So when you're looking at the system to buy out there and you're looking for milk quality detection, the systems that have the most different types of milk quality measures and combine those into their alert list are likely to be the more sensitive ones. And a subject near and dear to my heart is cow cleanliness. It is, without question, the biggest variable in incidence of new mastitis and bulk tank somatic cell count. We've known this for a long time, and we keep trying to get technical solutions to this in the milking parlor. And there have been some very, very clever technical solutions to try to clean teats better, clean udders better in the milking parlor. We try to spend an awful lot of effort trying to get people to do a better job of cleaning teats and cleaning udders before units go on. And the absolute certain conclusion from all the work we've done in conventional milking systems is that if cows are dirty when they come into the parlor, they're going to be dirtier after we prep them. So even our best preparation techniques by either robots or people will remove a certain percentage of the dirt, manure, bacteria on the udder surface. So this is, I thought, another great study showing that it scored udder hygiene before and after cleaning with a robotic milking system. So on the left-hand side, the level 1, those cows were level 1 or clean. It's a four-tier system, 1, 2, 3, 4. 1 is clean, 4 is absolutely filthy. So of the cows that came in clean, 95 to 100% of those were clean after preparation. Not a very bold claim on the part of teat cleaning devices. Of those that came into the parlor with level 2 contamination, only 50 to 80% were clean after robotic teat preparation. And of those that came in level 3 before cleaning, 7 to 57% were clean after robotic preparation. And these numbers actually look very much like what happens when people do the job as well. So the other result from this study was that there was greater success in cleaning the base of the teat using brushes, and there was better cleaning of the tip of the teat through the strip cup or the individual, the unit like the De La Valle unit that cleans with an individual teat cup. So the conclusion, prior contamination of cow teats influences cleaning success. Further emphasizing the need to get the barn right. And I've always been very, not a big supporter of retrofit dairy systems because you're just building in limitations. You're taking limitations from the past and carrying them into the future. So if you're going to invest, make a big investment in technology, get the barn right. It is enormously important for cow traffic. It is enormously important for milk quality. This is a little study that we did looking at comparing conventional farms to an automatic milking farm, and what we found is, in fact, the same. That the EMS did as well as good farms. The EMS was more consistent. So if you looked at the numbers were just a tad higher with the EMS, but they were very consistent. The numbers with people, on average, were just a tad lower, but they were very much more variable. So people let through dirty cows. That's just life. And the EMS at least will provide some level of udder and teat cleaning before the milking cups go on. Another study, somatic cell count at the bulk tank, positively correlated with portion of cows with dirty teats. Percentage of new cows with high somatic cell count positive related to the portion of cows with dirty teats before milking. And at the cow level, udder hygiene score was positively related with individual cow somatic cell count. So again, don't expect that you can clean up all the problems in the parlor, even with the best technology. This is just a bit of a summary piece from Sweden discussing the pros and cons of automatic milking in Europe, where they've had much more experience than we have. One of the advantages is that more frequent milking can be adapted to lactation stage. And I think this is really shown to be a clear advantage of voluntary milking, is that high-producing cows are milked more frequently than low-producing cows. And there comes a point in lactation, in production level, where milking a cow 3 times a day, a low-producing cow 3 times a day, does more harm than it does good. It doesn't really do anything particularly good in a late lactation, low-producing cow for purposes of production to milk her 3 times a day. And it introduces more risk of new infections because we're opening up the teat canal an extra time during the day. So I think that's a clear advantage of a voluntary strategy. And it's an interesting one, particularly looking at the automated rotary technology, whether or not to run it in a batch mode or a voluntary mode. So if we run a automated rotary in a batch mode, we're pretty much back to milking cows 3 times a day. I mean, that's the way people do it now on large farms. They milk all of them 3 times a day. And the voluntary mode would allow this advantage of automatic milking to be used. Increased milk production has been observed. There's also cases where it hasn't. The cases where it hasn't been observed, according to this author, were probably due to less attention paid to the management system. So again, the technology is secondary to the management. Automatic milking does provide more consistent milking routines. We know cows like that. Initial reductions in milk quality were observed, and there's some of the possible reasons for this. A lot has to do with just management again, but there are some issues related to somatic cell count that the variation in milking interval may cause a very slight increase in cell count. And I say may because the jury's still out on that one as well, looking into that. Positive influence on udder health. were observed in some studies, possibly as a result of quarter milking. Good cow traffic is a prerequisite for successful AM system performance. Grazing is commonly practiced. I guess we could say common. It's not the majority of automatic milking systems, but there are quite a number of systems in the EU that do use grazing. And the recommendations for a grazing system is reduce the travel distance from the pasture to the milking unit, and there was one other one on grazing. I guess I forgot what that was. And the final conclusion of this study, which we've seen over and over again, it is possible to achieve production level, animal well-being, and milk quality using automatic milking systems. There are lots and lots of producers out there who've done it, who are doing it today. So, in conclusion, automatic milking, the cows like them. I think my personal opinion, subjective opinion, is the cows like them a lot better than a traditional milking operation. And the people like them. There have been very few units that have been taken out, but by and large, when you go talk to people who are using automated milking technology, they're very happy with them for both reasons of milk production, milk quality, as well as quality of life. So with that, I'll close. I have 4 minutes for questions. So I talk too much again.
Did you ever figure out what it costs per cow?
I've done some calculations like that, and I would say in general, the way I look at it, if you're on a small farm, and by small I mean less than 500 cows, it's about equal to putting in a milking parlor on a small farm. And the reason for that is the milking parlor on a small farm is generally only used 6 hours a day or something like that. So you pay a lot for that technology, and you're not using it around the clock. This technology is used around the clock. So it's in the same sort of ballpark for a small farm compared to a conventional parlor. On a large farm with a large conventional parlor, it's more expensive. By something like about 50 cents to $1 a hundredweight, something like that. A single box system. We don't know yet what the automated rotary is. So talk to these fellows about a price, and then we can run some numbers on that. But I expect that the rotary technology will bring the cost down because you have fewer robot arms. You have less of the expensive stuff per the number of cows you're milking. So I think that's another real exciting possibility for that technology. Anything else? Yeah.
What's the driving factors in Canada that they're at 350 automatic milking systems?
Quota. Stable milk price. Less risk. Milk quotas favor technology. Low milk price works against high technology. Okay. It's a great pleasure. Thank you.
Yes, thank you, Dr. Reinemann, for your presentation, Automatic Milking, Current Status, and Future Options. Our thanks to De Laval for sponsoring this seminar. We hope you enjoy your visit to World Dairy Expo 2011, and please fill out the evaluation form and drop it at the back of the room as you leave. Thank you.
Hi, Jim.
Just had to check up on you, see if you were
Still alive.
singing a long time.